Hi everyone, I'm Federico Comotto, data scientist at LifeReply. Thank you very much for joining us today at this session, X-rays, the third eye. So before deep dive into this session, I want to introduce the company where I work, which is LifeReply. In LifeReply, we combine the vertical expertise on healthcare and pharmaceutic with the technological specialization on artificial intelligence, machine learning, and big data. So basically, we develop those innovative and technological solutions in order to solve real problems in the healthcare and pharmaceutical industry. Here you can see some of the use cases that we usually work on. They are, for example, medical imaging, radiomics, natural language processing, but also chatbot and behavior monitoring application. So if you want more information about us, please don't be afraid and email us at info.life@reply.it. Okay, let's start by looking at the agenda for today. I'm very excited. So we will start with the context where X-ray was born. Then we will move to what is X-rays, and then Alphabeto, which is an important platform that we develop, and it is based on X-rays. And finally, I want to make some conclusion about, of course, X-rays, but also on artificial intelligence more in general. Okay, let's start with the context. So here we can see some pain points in the healthcare industry, but more in detail, these are pain points in the mammography area. So you have to think about that 40 million of mammograms are performed in the USA every year. This is a huge number, and you also need to think about that we don't have enough expert radiologists to process and analyze all these images. So I think that it's time and we need some innovative tools to help radiologists in this process. Another important data is that the 80% of malignant tumors in mammograms are detected. This is what in machine learning we usually call accuracy. I think that this is a pretty high number, but we could and we also should improve this number, maybe by using some artificial intelligence. Why not? And last but not least, of course, is that according to the World Health Organization, 2.1 million of women suffer from breast cancer each year. This is, again, a huge number, and I think that we should help them in some way. So what is the story behind this data? The story is that we have a lot of images, we have a lot of mammograms, but we don't have enough radiology, at least expert radiologists, to analyze them. We are pretty good at the detection of malignant tumors in mammograms, but we could and we should improve. And finally, as I told you, we have a lot of women that suffer from breast cancer every year, and we should help them in some way. This is the idea underneath X-rays. This is why X-rays was born. Okay, but what is X-rays? Okay, X-rays is a medical platform. Actually, the CE marking is still going on process, and we aim at the second A category, which is basically a medical device to support diagnosis. And X-rays is based on deep learning and can be specialized in different modalities, such as X-rays or tomography, and different anatomical districts, such as the mammography or the chest. So at the very beginning, we develop X-rays on the anatomical district of mammography and using X-rays. Of course, X-rays is cloud-based because we need a lot of computational power, but we develop X-rays just by using some open framework based on Python. So I want to mention our journey. This is very important for us. So X-rays was born in January 2018 with a prototype for analyzing medical images. But in March 2018, we sealed an important partnership with a healthcare hospital in Pavia, which is Maugeri, to develop X-rays in order to identify any type of anomaly on mammography. And then in 2019, we sealed another important partnership with Treviso Hospital, in this case to detect the suspicious anomalies on in mammograms. And finally, in April 2020, we start with a new project, which is Alphabeto, and of course involved X-rays. And it was the main idea. It was to use X-rays in order to help and support the healthcare system during this pandemic. So, of course, there is a big community around X-rays. Here you can see just the milestone for X-rays. Okay, let's start with the very first specialization. That's mammograms. So the idea is that X-rays is able, by using deep learning, to take the mammography and then analyze the mammography and find some important information. This information is, first of all, the type of anomaly, but also the morphology of the anomaly, which is, for example, the shape, so in this case irregular, and the margin that could be speculated. So by using some artificial intelligence, some deep learning algorithm, we are able to identify important features in the mammography. These features are essential and pivotal for radiologists in their everyday job. So of course, this can really speed up and help the diagnosis and the work of radiologists. So before moving to the next part of the speech, I want to mention some important numbers about X-rays, because as I told you, there is a community around the X-rays and also important data. First of all, we trained the model over more than 20,000 images, where we detected more than 19 anomalies and 5,000 cases. So this is a huge number, especially for some training phase. Because of that, as I told you, we use cloud-based resources because we need a lot of computational power. As you can read from this slide, at least 10 servers and more than 50,000 iterations for the deep learning algorithm, because of course we need a good accuracy. And finally, we have this community around the X-rays that involve 10 partners, and also a community of radiologists that help us in the annotation of the images. That is an important and fundamental task. Of course, I give you just the idea of X-rays, the high-level idea, but if you want more information, please take a photo at this QR code. I'm gonna give you a couple of seconds. Okay, perfect. So now we are in the second part of this speech, which is Alphabeto. Okay, but what is Alphabeto? Alphabeto stands for All Faster, Better Together. Alphabeto is a totally different project which involves X-rays, because we thought that X-rays could help in the support the diagnosis during this COVID-19 pandemic. So the idea was to identify those patients that should go to the hospital or stay at home. But I don't know in the USA, I don't know in other country, but what we are seeing in Italy is that the hospitals are suffering because they are overfull, they are collapsing because they have a lot of patients. We need some way to simplify this process. So the idea was to identify the severity of the disease at the patient's home. But what is Alphabeto? So as I told you, Alphabeto is a totally new platform based, of course, on artificial intelligence, which aims to reduce the hospitalization by supporting and speeding up diagnosis of COVID-19. The idea came by the collaboration of three important parties in the healthcare system, which are, of course, Life Reply, so the company where I work, but also the Istituti Clinici Maugeri, which is located in Pavia. It is an important healthcare hospital, and also the University of Pavia. So I like to say that this is the excellence for a better healthcare. So, but let me summarize what is the process that involves Alphabeto. So, as I told you, the idea was to take care in some way of the patients at home. So think about that. We have some symptomatic patients that ask for assistance at home. At that point, a medical team visit the patients at home, of course, with the support of Alphabeto, of the platform of Alphabeto. At that point, the patient is subjected to some tests. First of all, the chest X-rays. So we take the images, the X-rays of the chest. And of course, we collect other type of data. We call clinical data. These data are, for example, the temperature of the patients, but also the saturation, and also the information about any type of disease this patient could have, such as diabetes, for example. And then Alphabeto starts with the severity assessment and the progression estimate of the COVID-19 disease. This is an interactive session where the model is able to perform a classification task, but also report and summarize all the information and share this information with all the healthcare professionals. We call this the reporting phase. At that point, the medical team, which is the support of Alphabeto, and also a doctor that is remotely connected to the platform, to the Alphabeto platform, figure it out what is the best strategy for the patient, which could be hospitalization versus home stay. Okay, let's deep dive into the technological component of Alphabeto. Of course, the machine learning process involves X-rays in some way. So this is the high-level pipeline. The first component is X-rays, as I told you. In this case, we use the capability of X-rays. In some way, we extend the capability of X-rays in order to extract, to use it as a feature extractor. So the idea is that by looking at the chest X-rays, we're able to identify some important features. These features are then combined to some clinical data, those that I told you before, temperature, saturation, and other type of disease, and feed to another model. This model is a classifier, and the task of this model is to identify if the patient should stay at home or go to the hospital. But please mind that at the very end, there is always the doctor that takes the last decision. As I told you, this is a platform, and a doctor will be remotely connected to this platform in order to analyze what Alphabeto says, and finally choose the best strategies for the patients. Okay. Let's look at the first component that, of course, is X-rays. As I told you, we use X-rays as a feature extractor. The deep learning model that we use is simply, let me say that, DesNet. So the algorithm was developed and trained in order to identify these 6 different features, which are consolidation, infiltration, edema, effusion, pneumonia, and lung opacity. We also identify and select this feature with the support of our expert radiologists, which of course approve all these features because said that these are the most relevant for the COVID-19 task, and also those features that the radiologists could observe in order to distinguish between patient with COVID and patient without COVID. So as I told you, these features are then combined to the clinical data that we collect at home, temperature, saturation, and so on. and feed to another model, which is a classifier. So let me explain this classifier. First of all, it's cloud-based, because even in this case, we need a lot of computational resources and computational power to train the model. In fact, we train more than 50 models by using AutoML. These techniques allows us to train a lot of model in a faster way. Of course, all the models are trained by using the cross-validation techniques, and the finally model that the best model is an ensemble one. So it's a combination of different models which perform pretty well. The AUC is 81%. That means that in the 81% of the cases, the model is able to distinguish if the patient should go at home or stay to the hospital. I think that this is a great result, especially considering that these are all real world data. So you can even look at the ROC curve of this model. So you can see the performance, the average of the performance of the model is far away for the purple line, which of course means random choice. So to summarize, we feed the model two different models, X-rays by using the chest X-rays. We combine the feature that we extract from X-rays with some clinical data, and we train another model in order to classify if the patient should go to the hospital or stay at home. So let me just summarize what are the advantages of this important platform of Alphabeto. First of all, we can take care of the patient at home. So we can test and we can check if the patient should go to the hospital or stay at home just by go to the patient's home. So we should not have anymore the problem of overfull hospital. Then we also have a dynamic triage, because there is this interaction between different components, the technology, which is Alphabeto, the platform, but also the medical team, the patients, and the doctor that is remotely connected. As I told you, we can reduce the access to the hospital because, of course, we can distinguish at the patient's home if the patient should go to the hospital or not. Another important aspect of Alphabeto that is an important advantage is that the information is shared in real time with the healthcare professional and the patients. In fact, we built a platform that is able to share all the information, so the data, the X-rays, images, and also the prediction, both with the medical team, but also with the doctor that is remotely connected. And finally, of course, we can reduce the clinical risk and define more and better and best and the best strategy for the patient. So we are really taking care of the patients. Okay, but now it's time for the conclusion. Okay, first of all, I want to summarize what is X-rays. So as I told you, is an artificial intelligence solution that use deep learning to analyze the medical images and support doctors in their everyday job. So it's very important to support in some way the doctors in everyday job. As I told you, for example, in the mammography area, we have a lot of images. We don't have enough experts, and we should help them in some way. And this is why we develop X-rays at the very beginning. But second, we can also inherently allows the inclusion of heterogeneous data to perform predictive analysis. So this is the case of Alphabeto, where we extend the capability of X-rays with another component, another machine learning model, in order to perform a prediction on the evolution of the pathology. And we were also able to combine structured data, such as clinical one, that we can collect at the patient's home, with unstructured data, such as the chest X-rays. And finally, this is very important, and I want to mention that we can improve the medical screening and reduce the diagnosis time, which means, of course, higher quality in medical treatments and reduction in clinical risk. I think that this is very important, especially for the healthcare industry. And finally, I want to say that I think that it's time for the AI. So AI is saying that disease costs more than health, and this is very true. Artificial intelligence, I think that is mature to help and support the healthcare system in the diagnosis phase, but also in other process. We can in some way automatize process. We can simplify process. So we can use big data and artificial intelligence to make the healthcare industry a better place. And in Life Reply, we develop this innovative solution based on artificial intelligence and big data to help the healthcare system, but also the pharmaceutical one, and to save lives. So I think that this is the real goal of our everyday job. So thank you very much for joining us to this session. Please, if you want more information, email us at info.life@reply.it. Also, don't forget to rate and review this session. This is very important for us. And please, it's time for questions. So if you have any question, don't be shy.